Any of that. All right, great. We are going to move on to something completely different this time. We're totally done with the gerrymandering stuff. The last thing we did was the isoperimetric quotient and the convex hull ratio. The rest of the semester, we're going to be talking about something completely different. And actually, this has nothing to do with politics. All of our things so far have been like vaguely politics related, and this is not at all related to any of that. Although I suppose it could have some relation on some level, but I'm not trying to go there. What I want to talk about for the rest of the semester is graph theory. Graph theory is a big deal in mathematics. You can't see that, can you? Something's... One moment, please. I don't know what's going on. Okay, I still don't know what's going on. Sorry. Yeah, all right. Graph theory. Okay, sorry about that. Graph theory is a big deal in mathematics. This is not related to the graph of a function, which I'm sure is something that you've all heard of and done a lot with in high school. Unfortunately, that thing is called a graph of a function. That's different from a graph in graph theory. So the word graph is used for two completely different things, and this is the other thing. This is not related to the graph of a function. Graph theory, you can see, like if you're looking at our grading checklist, there are many questions, D1 through D13, which are all about graph theory. I think probably we will not get that far through the list in terms of just covering all of that material, but we are going to get to quite a bit of it at least. And today we'll do the first couple of things on the list there. Graph theory, let me just tell you, a graph is a thing that looks like... by the way, I should say, I see a lot of people who like to take notes with their computers, and a lot of people maybe doing completely unrelated things with their computers, which is a little distracting to me when I notice. But this is going to be very hard for you to take notes with by typing because it's very much drawing pictures for everything. So graphs are fundamentally pictures that are impossible to type out if you're trying to do it live while I'm doing it. But anyway, a graph is a thing like this. It's sort of dots and lines that are connected in some specific way. All right, this is a typical graph. It has dots and lines in some kind of arrangement. And graphs are incredibly useful in all kinds of scenarios in mathematics and in regular life, I suppose. I don't know if people probably don't use graphs in their real life very often, but anyway, can we just... This is what graphs are all about, and we're going to talk about why such things might be useful for anything, and then what you can do using graphs in the real world, and abstractly also. So today's going to be mostly kind of basic terminology, or at least for the first 15 minutes or so. Everything that I say will be very easy to understand, I hope. These are made up of the dots and the lines, and the fancy language that we use for this is the dots are called vertices. That's the plural of the word vertex. One dot is a vertex. Several dots are vertices, and the lines are called edges. So the graph has vertices and edges. All right, and they are arranged in some way. Some vertices are connected to one another by edges. Some vertices are not connected to the other ones by edges. All right. Let's talk about some very basic concepts of in graphs. A graph, every vertex has a degree. the degree of a vertex, this is very important. I mean, it's very simple, but the degree of a vertex is a number associated to each vertex. It is the number of edges touching the vertex. Sometimes I'm going to write vert for vertex. So anyway, on this picture here, this vertex here has 2 edges, so its degree is 2. Maybe I'll just write the degree next to each vertex. Its degree is just how many edges are touching that vertex. The one down here, this degree is also 2, because I see 2 edges touching that vertex. All right? What about up top? Oh, this one here? Somebody want to shout it out? What's the degree there? 3. Yeah, you look just around this vertex, how many edges are going into it? And the answer here, this is 3. This one here, you could just look sort of around a circle around this vertex. I see 4 edges for this one. That's a 4. That's a 2. This is a vertex here. And then this one down here, that's a 1. There's only 1 edge coming out of that vertex. All right, that's the degree of a vertex. It turns out that when you're using graphs to do things in the real world, the degree is super important. Another thing that's very important in a graph is a path. You know, some of these dots are connected directly to the other ones, but some of them, like this degree 1 vertex is kind of far away from this one over here. They're not connected directly, but you can get from here to here on a path. So a path in a graph is sort of a sequence of edges, or you could say a sequence of vertices where each one is connected to the next one by an edge. So that's what I'm going to say here. It's a sequence of vertices connected by edges, sort of one after another. All right, so for example, if I had a graph that looks like, maybe I'll call these guys A, B, C, D. How about I'll put one in the middle? E, right? This graph here, what does a path look like? A path would be something like A, B, D, E, right? That's a path in the graph. And I could sort of indicate that path in my graph. It's, it's like this. Do-do-do-do-do-do-do. I'll put a little arrow there to indicate which way I'm going. A path always has a starting point and an ending point, and it goes along edges. A, B, D, E is that path that I wrote in red there. All right? Something which is not a path, not every sequence is a path. Like, for instance, A, C, B, D is not a path. That's because there is no edge from C to B, right? I can go A to C, but I can't go C to B. So A, C, B, D is not a path. That's because there's no edge from C to B. All right, so that doesn't count as a path. All right, that's what a path is. I think it's pretty straightforward. There's a special word for a path which begins and ends at the same point. You could call that like a loop. It starts somewhere, it goes around, and then comes back to where it started. That's called a circuit. So a circuit is a path that starts, I'll say starting and ending at the same point. Shall I say the same vertex, just to use a fancy word. All right, that's called a circuit. All right, and then one more basic bit of terminology. Actually, this one that I'm about to say is a bit more complicated. I want to talk about what it means for a graph to be connected. It's actually a very simple concept, but it's a little complicated to write down precisely what it's supposed to mean. So a connected graph, for example, this is connected. Something which is not connected will be something like this. Not connected. That's because, like, what's the difference? I mean, connected means kind of like it's all in one piece, but not connected. This graph here is not connected because it consists of two separate pieces. That's why it's not connected. But I want to actually, what I just said is not really a sensible, real definition to use for this concept, because I would like to write a definition for connected which doesn't involve the word pieces or something like that. Because if you say connected means it's all one piece, I would say, okay, what exactly do you mean by piece? And you would say, well, you know, it's like one thing, one chunk, one morsel. None of these are real mathematical terms. Does anybody have a suggestion about how you can say, actually you can make this definition in terms of the words that I've already talked about? What's really the difference between this one and this one? You got an idea?
Maybe that you can say if you are able to draw a line between the parts without cutting anything, then it's not connected. But if you draw a line.
This is an interesting idea. I think what you're saying is like if you can sort of put a my pencil's not working. What's wrong? Oh, this is a disaster. My pencil battery is out, I think. Sorry, can I come right back? I have a wire. I think I can use it while it's plugged in. Continue to think about what does it mean? Actually, so what I was going to say, I was going to object to what she said, because she said something like, if you can sort of draw a line that separates the two things into two separate parts of the plane. This is a good idea, although drawing a line is not so great, because you could imagine like this one. What if I extended this? This is what I was going to draw. What if I extended this into sort of a big ring that goes around this one, and this one goes around it? That still is not connected. It still has two pieces, even though one piece is kind of inside the other one. That would still count as two separate pieces. So think about it. I'll be right back. Sorry about this. I'm back. I hope this is going to work. My charging wire is only this long. I have this little extension for it. We'll see. Oh, this is a true disaster. I think I can't use it. I may have to switch to the whiteboards, if that's all right. Does anybody happen to have one of these things that I could borrow for the next hour or so? Or I can switch to the whiteboards. No. All right. I will switch to the whiteboards. And the folks at home, get bent, I guess. I don't know. I have no way of recording this. Sorry to the folks back home.